So I'm Chris. I am the co-founder and chief data scientist of TrustInsights.ai. We are a marketing analytics and management consulting agency. So we do a lot of um, helping organizations get value out of their data. When I'm speaking, honestly, the topics are all over the place. It really depends on what the event needs. I enjoy speaking about AI. I just released the third edition of my book, AI for Marketers. This is 50% longer and 100% less stuffy than the last version. But talking about the ways people can use machine learning and artificial intelligence to make their data more valuable, to get more value out of their data. I'm actually in the middle of writing a blog post right now about using basic natural language processing to reverse engineer search results, so that you can see, like, what did Google think was relevant in this pile of pages about, say, the search term of your choice. Because one of the things that I think is so challenging for marketers to wrap their heads around is that AI is just a technology. It's like a spreadsheet, right? You can use a spreadsheet for a bunch of things. You can use AI for a bunch of things. It's not magic. It's not mystical. It's just mostly math. And the real importance of it is what value you derive from it. But yeah, so how do you get more value out of your data? That's really, on all the topics I talk about, on stage and at events, it really is about making your data more valuable, getting you to take action on it. And something we say all the time is that data without decisions is a distraction.
Applications AI has for business. I mean, this would turn into a very long talk if you get into each of them. But what would your 5 most interesting or 5 favorite applications for the foreseeable future of AI in business be?
For marketers specifically, number one is attribution modeling, being able to understand what's working in a true multi-touch way, in a true propensity modeling way, which is a way of saying not just who visited from where, but what is the propensity, what is the probability that Facebook or Google or email actually played a role in getting somebody to convert. And that's something that we do all the time. There's content attribution, which is something almost nobody does, which is on your website, what content nudges somebody towards conversion? What's the most valuable pages on your site? And it's not always the pages people think they are. So that's a really good application. A second application is really just the technology is called dimension reduction or cardinality reduction. It's basically, if you got all this data, what of it matters? Which stuff actually matters? Marketers have no shortage of data today, but we're faced with data quality issues, which is a whole other talk. But what of all this data actually is relevant to the problem you're trying to solve? And again, this is something that technology can help you solve, but you've got to know to dig into it. A third one is who are the people that matter? So influencer marketing is huge right now, and people who are doing influencer identification are using software that frankly is terrible. It's like, who's got the most followers or who got the most engagement on their last 200 tweets? I mean,
but is there engagement a kind of value that does mean something? I mean,
it can. So again, this is where using some of these supervised machine learning techniques can really help. If you take all the data, followers, friends, counts, retweets, shares, likes, comments, wow, angry, the spectrum of all these different engagement numbers, and you model them against a response variable, a target outcome like leads, which of those variables have a relationship to leads? If the answer is none, then you know that engagement really doesn't actually matter for your marketing. If it's followers, and it can be sometimes, then guess what? You got to go get more followers. But the models that I really like for identifying influencers use network graphs. So network graphing is a relatively new technology. It's about 40 years old, I think. AI is about 70 years old.
70
years
really?
old.
Okay,
Yes,
I didn't know that,
the theoretical underpinnings of AI have been around since the 1950s. It's only in the last 10 years that we have, devices that have the computational power of, the entire planet 10 years ago that we carry around in our pockets. But network graphing allows us to understand who is in the center of a network. So I just did a Twitter chat the other day, and this Twitter chat has been running every week, and this year engagements were going just steadily to get down, 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 down. Okay, that's understandable. It's still a pandemic. But I said, what if we can bring in new and different audiences? So I built a network graph of all of the marketing Twitter chats recently, and said, who in all of these are the hubs, the people who are the conversation makers? And then I sent out a bunch of tweets in advance of the chat and pinged the top 20. And looking at the metrics a day later, it was the third most engaged Twitter chat of the year, fourth most in terms of unique number of participants, but it was the number one in terms of addressable audience, because we got a much wider assortment of people to participate and see this than previous events, and all through using network graphing. And you can use this not just with Twitter, we can use it with Instagram, you can use it with academic papers, news articles. Who's influential? These are techniques that are readily available. And again, this actually is, and I apologize for being that guy, but a lot of this is detailed in the book in terms of how do you use this stuff. The fourth technology.
Show us the cover. I'd like to check it out myself.
Oh, sure. If you want to, you can find it at aiformarketersbook.com. Pretty easy to remember. The fourth technology, and the one I think is probably the most interesting, is natural language processing. How do you digest a large amount of text and data, or even non-text data that is transcribed to text, and make sense of it? So a fun example, a couple of years ago, I was asked to help this recruiting company improve their ads. They're trying to attract new candidates. And so we took all 5,000 of their job ads, washed them through natural language processing, said, what are the most important and frequent words and phrases in their ads? And it was things like, you must have this CDL license, you may have this, and this, all these things that the company wanted. And we took 17,000 phone calls from their call center and put them through transcription software, got the text, ran the same model. And they were all talking about things like pay per mile, my home on the holidays, what kinds of loads am I carrying? And we said to the company, look, these two data sets aren't even dining at the same restaurant, much less the same table, right? You're talking about one thing, they're talking about another. Of course, you're not getting any responses to your ads. You are talking about nothing that these people want to hear about. You're not telling them about their pay. You're not telling them about their holidays. You're not telling them about their work time. And so they changed their ads to include a bit more of that data. That's like a 40% increase in performance immediately.
Is there a difference in the terminology, or is it exactly the same? AI and machine
It's not the same. AI is an umbrella term that means you are trying to replicate natural human intelligence with machines. So that include things like speech and vision and comprehension, and even tasks like empathy would be something that people are trying to replicate with artificial intelligence. Machine learning is a subset of that. And it is essentially what it says. A machine is trying to learn and write its own code from data we give it. It's a reverse of the traditional software process. So normally, we humans write the code, and then the machine spits out results, right? Every time you play Candy Crush on your phone, like, humans wrote the code, and then you're dealing with the data outputs. Mm-hmm. Machine learning is the other way. You take a lot of data and you tell the machine, learn from this and write your own code. And then we'll feed it new data and keep it running. And so the machine adapts over time. This is why there are so many potential downsides to AI, because it's garbage in, garbage out at a much, much bigger scale. If you feed machines tons of data and all the data is bad or biased, you will create, the machines will write software that essentially tries to do the same thing. Here in America, for example, there are a lot of people trying to apply AI and machine learning to healthcare data to say, okay, can we predict healthcare outcomes? Can we improve healthcare outcomes? We have such a history of systemic racism in America that all of the healthcare data about Black Americans, all of it, is compromised. Right? You cannot create an optimum healthcare outcome from the existing data, because bias in society is so bad that you can't effectively forecast or make recommendations. You actually have to add in data from other populations into Black American healthcare data, so that you can say, like, yeah, you're supposed to live to 78 years old, not 72. You're supposed to have this type of blood pressure on average, not this type. And one of the biggest challenges people have is that we have to recognize, A, is the data going into the machine biased? Are the people who are building the machines biased?
What kind of jobs would AI completely take over? Where would it not make sense for any individual to try and take that as a career path, because it's sort of, like I said, imminent that AI would take over?
AI doesn't take away jobs because a job is a collection of tasks, right? AI takes away tasks. The more repetitive your tasks are, the more likely it is that can be eventually automated, right? I used to work at a PR agency, and there's this one task that the junior members had, which was appalling. They would just copy and paste stuff from Google to a spreadsheet all day long. I'm like, how have you not clawed your eyeballs out yet doing this job? That is clearly a task that, and that job, like 90% of that job absolutely could be automated away because it was one task of copying and pasting, which is a stupid job. But what will happen is, if you think about, I have 8 units of work a day, 8 hours a day of work, right? And they're all different tasks, but I can have AI do 3 of those 8. So now I perform 5 units of work a day. Now, if it's just me, that's fine. I have 3 hours extra in the day to do some interesting work. But if I have 100 people like that, suddenly I've got 30% excess capacity, and now I can reduce the number of people while keeping the same, each person having 8 units of work each day. But because AI has taken 30% of those units away and done them, I can now reduce the total number of people employed. So the job itself, marketing coordinator, marketing manager, doesn't go away. But the number of people I need to do all of the work will decline in some ways. The flip side is there will always be things that, at least for the foreseeable near-term future, machines simply cannot do, right? Machines cannot express empathy, which is knowing what somebody's going through and then making a decision based on it. Machines cannot feel. They can emulate it, but they cannot feel, and so they cannot make empathetic decisions. They cannot violate their own rules. Like, you go to a restaurant, right? Back in the days when we used to go to restaurants, and you see the server was having a hard time, and you're extra nice to the server, and they're like, you know what? You're the first customer I've had today that wasn't a complete jackass to me. I'm going to give you an appetizer around the house. They broke the rules because they exercised judgment. Machines can't do that. They literally are the rules. Right now, all AI is what we call narrow AI, which means it's really good at a task. Machines cannot cross domain. There is a concept called transfer learning that is starting to get there, but it's not quite there yet. But say you're a video gamer and you're really good at making decisions, in a 3-on-3 arena battle. You can mentally take that concept and apply it to a soccer match, right? It'd be very difficult for a machine to do that kind of cross-domain thinking. It's just not there yet. So those are those are the things that machines won't be able to do in the near-term future. But yeah, the golden rule is, the more repetitive your job, the more likely it is that good chunks of it will go away.